it's, compared to PageRank, on which the papers were being published in 1998, it's more classical. Okay, not compared to, the usual ADPC kind of standards. Okay, so the idea is that okay, so clustering essentially is the process of grouping similar objects together. Okay, and that's just a general idea. You can cluster anything. Okay, what I will do in 1.5 or so lectures here is talk about general clustering algorithms, some of the classical clustering algorithms, with an eye towards clustering text. Okay, so basically it turns out that all that you need to understand clustering is distance between objects. And objects that are closer to each other are in one cluster, and as a group, all those objects are far away from these objects, these are in a different cluster. Okay? As soon as you have a notion of distance, you can have a notion of clustering. Okay? Of course, how do you define distance? That depends on the domain that you are looking at. For text, the distance would be our similarity measures. We could use vector similarity or checkered similarity, for example. Okay? And so, with that in view, we will basically look at what would be, how would classical clustering algorithms work for text. Now the question is, why do I care? That's mostly what I want to talk about today. Why do I care? Because in search, in IR, you might want to structure search results. So instead of just saying, here are the 100 results, or here are the 1,000 results for your query, I can actually cluster these 1,000 results into 3 groups of varying sizes. And say, here is one cluster of results, here is another cluster of results, here is another cluster of results. Now, this could actually have the same effect, some of the same effect as the one that LSI and correlation analysis was trying to do. So for example, if I had said Bush, okay, there may have been in the top 1,000 results some number of George Bush results and some number of Kalahari-Bushman results. And hopefully, if my clustering is good, it would have picked all the George Bush results and said one cluster, all the Kalahari-Bush results and said another cluster. Okay, then if I show these 2 clusters to the user, in essence, if I did not know upfront which Bush he or she was talking about, now I provide both of them, and whichever cluster they click on, that's the one from which I'll show more results. Okay, so in general, clustering is considered to be a good way of understanding the intent behind the queries. Okay, that's a very useful thing. Okay, the other interesting thing about clustering is that if you click a page, then if this page is part of another cluster of pages, then you might say you might be interested in these other pages in this cluster. Okay, a third idea is if you cluster pages, you can compute essentially taxonomy of pages on the web. You can compute the directory of the web. Okay, and then finally, if you cluster, then you can also use that to figure out essentially the topics, of the pages, and then also sometimes look at which are likely to be closer to each other. Okay, so I think these 2 are very compelling applications. You want to cluster your search results. In fact, on part 3, either I require or you get to do, if you want, in part 3 of the project, clustering of search results. Okay, and that's one way you can figure out whether this thing actually works well or not. Okay, so one other question, of course, is, so there used to be the case that there were a large number of search engines, but now obviously there are only 2, and neither of them directly use clustering. Okay, but there used to be, some of them may still exist. This is from a while back. There used to be this search engine called Plusty, which would actually do exactly this, clustering. And there was another search engine called Manjaro, which is again a prototype, which used latent semantic indexing followed by clustering. Okay, the idea is that if in fact the real representation of these documents is in the LSI space, then you should be looking at their distances in the LSI space, not in the normal space. because the distances in the normal space may not be telling you really the true distances. So they would do LSI on the top 1,000 results and then do clustering using one of the methods we talk about, k-means or something like that. Okay? And so that's basically what we are interested in doing clustering. Now, so in terms of when do you do clustering, you can do clustering at the indexing time. That means when you actually crawled all the documents into your corpus, and then you are constructing like the corpus, or you're constructing similar documents kind of clusters. Okay. You can also do it at the query time when you are essentially looking at putting all the George Bush results in one cluster and Kalahari Bushman results in a different cluster. Okay. And then the clustering can also be based in terms of the distances. The question, of course, is when you're talking about clustering, and we'll do this next class, you need to decide how do you define distance between pages. Okay. One obvious idea would be to define distance in terms of the text on those pages. But on the web, you can also use a link structure to decide distances between pages. So for example, two documents, both of which are pointing to the same 18 pages and are being pointed to by the same 17 pages, are probably similar, even if they don't think they are similar. Okay, so then that would be a link-based, so URL-based distance, text-based distance, which is what we'll mostly look at in the classes. But URL as well as the link-based distances can also be used. Okay, I'll stop here. Next class, I'll spend some time talking about general ideas of classical clustering and how to apply them to text.